Section 4.5, page 3. Taking a look at an example with differentials, we are given that y is equal to the square root of x, x is 4, delta x is 1. Find dy and delta y, sketch a graph, and indicate line segments whose lengths are dy, delta y, and dx. All right, personally, I like to do the sketch a graph part first. So, and when you do these differential graphs, you need to draw them pretty large and very much out of scale. So I'm going to put a break in here. Y equals the square root of x. There's y equals the square root of x, and we're looking at this from x is 4 and with a delta x of 1. So let's put in 4 here, and delta x is 1 puts 5 way down here. All right, clearly that's why I put the break here, because there's no way, if this distance is 1 unit, that distance is 4 units. So I put the break here. Probably should break this graph as well. All right, so now line the verticals up. And draw in the horizontal from the initial x value okay. At this point then you can identify what change in y is. The y value changed from this y value all the way up here to this one, which is this amount right here. That's change in y. That's change in y. Now draw in a tangent line from the original x values at 4 there's that tangent line. Go back, we're going to have to extend this vertical up. And now we want to look at how the y values change if we follow this brown tangent line. And those y values change by this much right here. All of that is dy. Okay. Let's see. Sketch a graph, and so we've got dy, delta y, dx. Dx is right down here, and dx is exactly the same thing as delta x. Because if we're following the curve, the function, or the tangent line, the change in x value is exactly the same thing. All right, now, so we've got the graph part with everything labeled. Let's go back then and let's find what we're supposed to find. So we want to find delta y. Delta y is the change in y values. So it is the function evaluated at 5 minus the function evaluated at 4. Our function is square root of x. So square root 5 minus square root 4. Square root of 5 is about 2.236 minus 2, so 0.236. dy, to find that one, start off with the equation y equals square root x. Then let's rewrite this as x to the half do a derivative, but when you do the derivative, use the dy dx notation. Oops, I have to actually do the derivative, huh? So that would be 1/2 x to the negative 1/2. I'm going to rewrite that as 1/2 square root x. Now, multiply by that dx. So dy is 1/2 square root of x times dx. And plug in the information that we know. For this problem, the original x value was 4. So 4 here times, and then dx is 1. dy then is 1/4, or as a decimal, 0.25. All right, going back. Delta y 0.236, dy 0.25. Are these close to each other? Yes, they are. And when we come back and look at the picture up here, it absolutely makes sense then that delta y is numerically 0.236, which is smaller than dy 0.25.